Okay, this is my attempt to show you a monohybrid cross, which just means we're looking at one trait at a time. You can do most of the stuff they seem to be talking about with these. You just show them differently. It's a quicker tool to help you calculate percentages if you don't want to just memorize them. So this one is particular. I'm doing cystic fibrosis, which I'm showing with the CF because that's not standard. It's just how I'm showing it. If it's a big C, that means that you are not going to have cystic fibrosis. And I'm ignoring the different, like I know there's different severities, and I'm not entirely sure how each one is transferred. I don't know if it's polygenic, meaning more than one genes that cause that, or if it's individual issues. I don't know if it's epigenetic. I don't know. I'm sorry. So we're going simple. So the big C means that the person is normal. If they have only little c's, and I'm just denoting a C looks like a C, so I just put a line over it. You don't have to. That's just my mark. So that means that the person, if that's all they have, they will have cystic fibrosis. In most cases, people may not know that they're carriers unless they've had people with cystic fibrosis in their family and have had some sort of genetic testing of their own. And again, cystic fibrosis is, well, you know more about it, I'm sure, than I do. It has to do with the salt membrane barriers, and that, they create a lot of mucus, and there's digestive issues and infections that occur in the lungs and so forth. It's more common in Caucasian Americans here than it is in other groups, but it can occur in other groups, but it's more common. So the normal person who has children with cystic fibrosis probably does not know that they're a carrier unless they're tested for whatever reason. So the mom would be normal. This is a big C, little c, because they have the big C, they're normal. And the little c, of course, denotes having the trait as a possible allele to give your children. But that doesn't mean that she has it in any way, because she does not. But she is what they would call a carrier. And the same would be true of the father. He's a carrier because he has two genes. This is not a sex-linked trait. This is a trait that's on an autosome, which is a regular chromosome. And it's a 2 allele, 1 gene trait, which most traits are not, but this one is. So what happens is that we want to show the cross. So here's my box. One parent's genes go across the top, one go across the side. I was taught generally the females go across the top. It really doesn't matter, just so you keep that person's genes or animal's genes together. So you would take these 2 letters and put one over each box, whatever those letters are. And in this case, it's big C and a little c. Now, the dad has the same letters. I'm going to put him here, big C, little c. Now, you don't have to use colors. I'm just using them to show you where this goes. So it's kind of like bingo or battleship. You bring both letters over. If there is a large letter, it goes first, just out of convention, because it makes it a whole lot easier to read. So in this case, this is a big C. It's going to go into this box, and it's going to go into this box. Her little c, I just automatically put any first little one I see on the other side. So that's the mother's genes accounted for. The father, big C, moving that across. Big C, big C. Now, it wouldn't matter which mother genes, it doesn't matter which big C's first. I'm just showing you that's how it would work. In this case, he has a little c, so little c, little c. So these are their genotypes. The actual possible offsprings genotypes of these 2 parents. So when we're doing any calculations, we leave these parents out of those calculations, of course. So you're looking at big C, which means that the person is normal. And they're not even a carrier. That's an entirely normal person. The big C with the little c, they have a big C, so they're normal. But they also, that's their phenotype, the way they look. A picture kind of them, the trait they have. And then their genotype are the letters, the big C, little c. But this is a normal person who is a carrier, probably would not, again, not know it at that point. Same thing here, big C, little c. This is a normal person that is a carrier for that trait. Okay, then we look at this one, little c, little c. Well, this is a recessive disorder. So this is the person that the probability that you would have cystic fibrosis. And then you're looking at, there are 4 boxes, like 4 quarters. So this is 25% chance that they're going to have cystic fibrosis, that your kids, each time you have a kid with these 2 parents, there's a 25% chance that you're going to have that trait, that you're going to have cystic fibrosis. 25%. So if you have one child with cystic fibrosis, you automatically know if you're going to have another child, there is a 75% chance that that child is going to be normal, but there's a 25% chance you're also going to be having to find treatments and deal with medical situations of another child with cystic fibrosis. So that they have cystic fibrosis. Now, you can also do this as a probability, which is just a percentage. And in this case, 1 out of 4 boxes is the probability. But I don't think they're going to ask you that kind of stuff. So this is just a general one trait situation.